Hey, welcome to The Explainer. Today, we're going to dig into something we all think we know, the number 0. But what if I told you it has this whole other side? A side that's actually full of really surprising secrets.
You know, we all learn how to count up. 1, 2, 3. Simple enough. But what happens if you go the other way? You go back from 1. You hit 0. Okay, but what if you just keep going? Is there such a thing as less than nothing? Well, that's the big mystery we're going to crack today. And our story starts in a pretty fun place.
All right, to get our heads around this, we're going to visit a place called Biela's Building of Fun. So yeah, forget the boring equations for a second. We're going to think about all this with elevators and toy stores. It'll make sense, I promise.
Okay, so welcome to the building. Here's the layout. The main entrance, this welcome hall, that's floor 0. That's our ground level. Super simple. If you go up, you're on a positive floor, like let's say the food court is at +1. And if you go down, you're on a negative floor, like the toy store down on -1.
All right, you ready? Quick pop quiz. You're up on floor +2, you're checking out the art center, you get in the elevator and you hit that down button 3 times. That's a move of -3. So think about it. Where do you end up?
And you arrive at the toy store on floor -1. See? Just like that. You did the math without even really trying. Our little elevator trip is just a picture of this equation. You start at +2, you add a move of -3, and that lands you right on -1. Pretty cool, right? So, this building gives us a super clear map for all this. Positive numbers, they're just the floors above ground. Negative numbers, the floors below. And 0, well, that's our welcome hall. It's that crucial middle point. It's not positive, it's not negative, it's just 0.
And the building makes comparing numbers just incredibly easy. I mean, a higher floor is always a bigger number, right? So +3 is obviously way higher or greater than +1. But here's the really cool part. The same exact logic works below ground. Floor -4 is lower down than floor -2. So that means the number -4 is actually less than -2. It feels a little weird in your head at first, but when you picture the elevator, it makes perfect sense.
Okay, so this building is a fun way to picture things, for sure. But this whole idea of numbers on both sides of 0, it's so much more than just a game. It is absolutely essential for how we describe the world around us. Let's take a look at what I mean.
Think about your bank account. A deposit? That's a positive number. Your money goes up. A bill or a purchase? That's a negative number. Your balance goes down. So let's say you start with $100. You deposit 60, now you're at 160. Cool. You pay a $30 bill, you're at 130. But then you make a big $150 purchase, and oops, your balance just dipped below 0 all the way down to -$20.
You see the exact same logic in geography. Sea level is basically our floor 0 for the whole planet. A mountain peak, that's got a positive height. A super deep ocean trench, that's got a negative depth. It's the same idea as our building, just, on a massive planetary scale.
And what about the weather? I mean, when we talk about temperature in Celsius, 0 degrees is just the point where water freezes. But things can get way, way colder than that. A temperature of -4 degrees, like on a freezing night in Leh, that is a very real and very, very cold negative number.
So we've got elevators, money, mountains, all using the same logic. Now let's connect our little fun analogy to one of the most powerful tools in all of math. It's time to show you the actual blueprint behind Biela's building.
Okay, let's stretch our imagination a bit here. Imagine that elevator isn't in a normal building anymore. It's in an infinite lift, inside some crazy deep mine shaft that goes up forever and down forever. There's no top, there's no bottom. Just an endless ride up and down from that one starting point, level 0. So picture that. This infinite vertical line of numbers, going up into the sky and down into the earth. But here's the really interesting question. What happens if we just take that whole thing and turn it on its side?
It becomes the number line.
That's it. This is the secret blueprint. Our fun little up and down elevator shaft is the horizontal number line you see in every math class. Going up is just moving to the right, into the positives. And going down, that's just moving to the left, into the negatives. It was there all along. And you can use it exactly like the elevator. Let's say you want to solve 3 plus -5. Simple. You just start at the number 3 on the line, and then you move 5 steps in the negative direction, which is to the left. And where do you land? Right on -2. See? The visual tool and the abstract math, they're exactly the same thing.
You know, now that we see it laid out like this, it seems so obvious, doesn't it? But what's totally wild is that this simple, elegant idea had to fight a long, hard battle just to be accepted. For centuries, brilliant people thought negative numbers were strange, illogical, even absurd. I mean, check out this journey. Way back in the 2nd century, accountants in China were already using different colored rods for profits and losses. Then, in India, in 628 CE, the amazing mathematician Brahmagupta wrote down the first complete rules for them. But get this, it took another 600 years for that idea to even get to Europe. And then it took centuries more before people stopped looking at it sideways. The doubt was real. I mean, even in the 18th century, that's not that long ago, a respected French mathematician, Lazare Carnot, wrote this: "How can we subtract a greater number from a smaller one? It results in absurd quantities." Absurd quantities! Can you believe that? To one of the top minds of his time, the whole idea still just didn't make sense. And this is what makes Brahmagupta's work just so incredible. The rules you see here, he figured them out over 1,000 years before Carnot was calling them absurd. And they're the exact same rules we use today. He knew that taking away a negative is the same as adding a positive. He had cracked the entire code in his head way back in 620.
So this absurd idea that took literal centuries to catch on, it's now completely fundamental to how we see our world. It's in our money, our weather, our geography, everywhere. Which kind of brings us to one last thing to think about. What part of your world, your day-to-day life, would be totally impossible to even describe without the other side of zero?